If I can start, can you wave just in front of the camera or something? Okay, awesome. I'm gonna start. Hi everybody, and well, it's finally my turn to speak tonight. Thanks for waiting out for me so long. But everybody calls me Orly. I'm on Twitter. You can follow me at Orly Soros. And I basically moved to Texas a few months ago. And before that, I used to live in London, where I used to be a software developer for a few cool companies. I used to work in the API space. And therefore, I built a lot of APIs and tools that work around APIs. And the first time that I really got my hands on the Internet of Things, like the first time I heard the word Internet of Things, I was at a hackathon and I was trying to get an Arduino to work and to build something really cool. The idea was to basically use a bunch of LED lights to be controlled with a telephone so that I could switch them on and off depending on how I wanted to have the lights in my house. And that's the first time that I really kind of got my hands on with the Internet of Things. So today I just wanted to first take a step back and see how many of you exactly know what the Internet of Things means, right? There's a lot of description of what the Internet of Things might be. And the Oxford Dictionary gave a definition as that, the Internet of Things, it's a proposed development of the Internet where everyday objects have network connectivity, allowing them to send data and receive data. And then Wikipedia decided to give another definition, but I think the best definition of what the Internet of Things is it's to connect every object in order to make the process more efficient and in order to provide comfort or improve our life in both a work and personal context in any kind of way. In the Internet of Things principle called the 3 big A's. The first A, it's always, and means that devices are always connected. The second A is anywhere, which means devices can be anywhere in the world, obviously depending on climate and technological, conditions active. So it means to be always connected, able to send data to a server in a way or another. So the question is, why does Internet of Things matter? Why do I care if I can switch on my telephone and be able to control the lights? Who cares if my thermostat at home can understand how I like to set the temperature in my house, summer or during winter? Who cares if it can learn? Who cares if in my garden the water sprinklers outside can detect when it's the right time to switch on and throw water at all the plants? Well, the reason is that we are humans and we're poor data collectors. We're not very good at collecting data in a timely and efficient way. We sometimes have different perspectives, different perception of, for example, what heat is, what temperature is, and therefore we rely on machines. The Internet of Things is predicted by the Cisco. Cisco is basically this huge company that does a lot of networking equipment, and not only, they also do a lot of other stuff. But they predict that by 2020, so in basically 5 years, there are going to be 50 billion devices. This means that every person will be able to be basically outnumbered 8-to-1, which means there will be 8 devices per person. And not only that means there are going to be way more internet-connected devices, there are also going to be a lot of major markets that will be revolutionized by the Internet of Things. Today, in 2015, 150 devices connect to the Internet every second. That is an enormous amount of time of connected devices per second. And it's only going to be a larger and larger number. So let's look at some of the Internet of Things devices that are out there today. Some of the more simple ones are hue lights, which are the ones that I got started with, which allow you to control the light color, and you can control the intensity, the brightness, and all that through a simple application. This can be used, for your own house. It can be used in a disco. It can be used in a medical environment, and there's different benefits that are basically received when you basically have different light colors and different intensities. And the device is this one here. This one is a doorbell, which is also a webcam, and it's connected to the internet and allows you to see exactly who is at your door so that you can decide to open the door or not. If you don't want to open the door, you know exactly who is in front of the door, and therefore you don't have to open it. One of my favorite ones is because I love to sleep. So this is a cover for your bed that you put under your bed sheet, and basically turns any bed into a smart bed to improve your sleeping patterns. The company is called Luna. The product is called Luna, and it was like one of the Stanford's startup accelerator program winners. So if you have, like, for example, troubles in sleeping, you should consider, maybe getting one of these and see how it would give you a better solution. It gives you like a recommendation on how you sleep better. But that's not all, because here we go. We have like Internet of Things in your training gear. It's on your babies. It's on your bottles and on your containers. So there's literally Internet of Things everywhere. Are we turning into Skynet? Well, are we going to be becoming, kind of like the movie where the Terminator and there's the Skynet? Well, I don't think so. But hey, who knows, right? So the Internet of Things is literally all over the place. Like, in other cases that I didn't mention are in environmental monitoring. So you want to know how much pollution there is, how much noise, etc., etc. In infrastructure management, you want to, for example, manage different things that have to do with infrastructure. So, for example, the status of something. And you can track all this thanks to the sensors, to the Internet of Things. Energy the energy industry is huge for the Internet of Things, with all the smart meters that are being rolled out, especially in Europe and in the West. And then obviously you have the medical and healthcare systems, where doctors they can track patients' health in a more efficient way, but so also in transportation, games, and like I mentioned before, sports and fitness. The Internet of Things is going to be literally everywhere. It's on you, on your body, as for example, a ring or an elastic band, or in your pocket, or in your shoes. It's going to be in your home as as a door lock, as a thermostat, as a light, as in your garden. It could be also so people that have large industries, they will be able to control different aspects of their everyday processes. And then finally, it literally could be citywide and be able to provide data on waste management, parking, the lighting system, public transportation, and so on and so forth. But if you can look on this graph, you can see that the Internet of Things, it's mostly the Western countries. If you look at the bottom of the graph right here, you can find that Brazil is number 15 with 9.2 Internet of Things devices deployed per 100 inhabitants. But that's a good thing, because if the Brazil is up here, in a couple of years it's going to jump somewhere around here and take over the other countries because of the way that Brazil is growing the markets and the economy. So that's all good stuff. So let's look quickly. As you can see, the Internet of Things was not a thing until somewhere in 2013, where Google says, "Hey, look, it starts to go kind of a hockey stick kind of growth," and that's when people started talking about the Internet of Things, and it became a buzz. And the reason why that is probably because of the introduction of devices like Arduinos and other similar devices, where students could try to develop some kind of Internet of Things appliances with their own computer for a very, very cheap cost. And therefore, everybody was excited to become not only like a software engineer, but also like a hardware hacker. A friend of mine, for example, like a few years ago, he created his first Internet of Things device, which allows him to open the garage door with an SMS. And the garage door also knows who opened the door, because it tracks all this data. And it's really interesting because the problem he had is that his garage was shared with another 4 or 5 people, but he didn't have enough keys, and his landlord, the person he was renting the garage from, didn't want to make copies. So it was very, very stressful. And that's why he went ahead and said, look, I can create this little device, I can put it in my garage, and eventually I can put it on other doors, and it will be all connected to the internet. So that's cool, but how does the Internet of Things work? Well, every device needs to be able to send and receive data, otherwise, it wouldn't make any sense. And then every device might be able to talk with another device through something that is called mesh networking. Finally, what's probably most important is that every device needs to be able to split a server or a broker, and that means that all the data that is collected by the device is then sent to the server and then aggregated, analyzed, and then made available, hopefully a REST API to all of the people that want to create applications or just access the data. And all these devices usually take advantage of something that is called a messaging protocol. There are a lot of different messaging protocols. You've probably heard of MQTT, which is probably the most famous one. And MQTT stands for Message Queue Telemetry Transport. And it's one of the hottest protocols used to allow devices to talk one another in Internet of Things using a method that is called a pub/sub protocol, which means devices can publicize their information and then they can subscribe and then retrieve information from the message queue. And it's obviously, like I said, one of the most famous protocols that probably is the mostly widely adopted out there, and therefore you should probably consider spending some time researching it if you haven't already. It's very power efficient, means that it saves a lot of battery and works with devices that are not very, they don't have a really good computational power, which means it's good for small chips. Another very old protocol is called XMPP, which stands for Extensible Messaging and Presence Protocol. It was used mostly for real-time communication technology back in the days. It was used to do until today, and it's also used for like desktop and mobile apps to exchange information and communicate. So mostly of the chat messaging system are probably built on something like XMPP. It's very flexible, and XMPP has a lot of extensions for the protocol and software-wise, so it's very reliable. Next one is AMQP. It's another queuing system to connect servers with another. But and the list goes on. There's BBBS, there's WAMP, and there is CoA. And that's one of the most recent ones that is really interesting because it's what stands for Constrained Application Protocol, and that means that some devices have very, very low computational power and bandwidth available, and therefore they need to use a protocol that really minimizes the overhead. And CoA, if you're interested in protocols and building your own Internet of Things company, startup, or devices that uses small devices, CoA is probably what you should go for. So what the hell? What is all this? Why am I telling you all this stuff? Well, how do APIs? Well, that's because there's APIs, and APIs fit in here in this particular way. So at the top, you have any device that you might have created that usually might be able to connect directly to your mobile app using NFC or using Bluetooth. But usually this is not the preferred way. Usually the preferred way is that the Internet of Things device that you created connects using a protocol like, for example, MQTT to some kind of like broker, which then connects to the cloud, and that's where all the data is stored. And then you ask yourself, okay, now that all the data is stored on the cloud, how am I going to retrieve this data to send it, for example, create a mobile app, or show it on a website, or create a dashboard? Well, that's where APIs come in play. And it's really important when you understand this, because APIs make it super simple for developers to create anything with data that you provide to them. Okay, so all this data that is stored in the cloud, as a developer, you want to be able to access it. And like I mentioned a second ago, you might want to create a REST API that allows developers to simply and very quickly retrieve the data from the data store, from your cloud, where you store all this information that you retrieve through your sensors, with Internet of Things devices, and so on. And you want to be able to give this data to developers so that they can create stuff. And developers are very lazy. I mean, I'm a developer. I will take the first shot. I'm very lazy. I don't want to learn new technologies every other day. I mean, it can be exciting, but as a developer who's doing a job, I want to be able to use the technology that I already have very good familiarity with. So that is, for example, REST APIs, JSON format, OAuth authentication, etc., etc. My end goal is that I want to build something that works and is fast. And this is kind of how the web works, right? Where you have like clients, they connect to some router or proxies, and these router proxies connect to some servers that usually have like APIs, have data, and all that kind of stuff. In the same way, you should know that like the REST, like I mean, the whole this whole like REST API that usually sits somewhere in this cloud allows you to like exchange data between the multiple servers and the client. So just for a refresh, if you guys are not very technical or if you don't know much about REST API, but basically it's a simple way that if you're given a domain name and you do like a verb, so you say, I want to get something off this domain, you basically specify here the resource name and then you can add some filters here. So for example, if I wanted to retrieve, I don't know, like all the cats, imagine I stored images of cats on my server, I would probably have an endpoint called animals, and then I would probably have a filter that then, you know, like what type of animals I want cats, right? So this is kind of like a simple RESTful endpoint looks today, in very simple and fast. So, talking about APIs once again, this is kind of how it looks like. This is a picture that I took from the Amazon Web Service website, and it shows that, you know, you have a sensor, and this sensor wants to communicate with some kind of broker, and the broker basically makes sure that all the sensors together they can like transmit data and then send this data over to the cloud. And here the cloud is basically where all the data is stored inside one of the in a database, and here is where all the magic for the API management happens. Because this presentation is, you know, API management for the Internet of Things. So all this Internet of Things literally. They communicate data to some server infrastructure, and then this data is then available through a gateway, an API management gateway to devices like your mobile phone, your website, or something. And then this big server also decides when, you know, through the same broker, it decides how to send data out to the other sensors that might be part of your network. So I worked on this, which is called COM. And COM is basically an API gateway that allows you to manage your APIs in a very simple way. This way, you don't have to build, again, authentication. You don't have to build, again, rate limiting, and all the feature that the Internet of Things might need from you. And the way COM works is basically, it's a scalable and modular infrastructure agnostic API gateway, reading it from the slide. What does that mean? Well, it means that, you know, with COM, you can put it on anything, on Windows, you can put it on Linux, it can run anywhere. It's modular, it means that it can scale. So if you have 10 APIs, or if you have 1,000 APIs, or if you have 1,000 APIs, it can work. And it's modular because how we will see in a minute, you can extend its functionalities. COM was built, and I was one of the guys that built this software. It's built on top of Cassandra and NGX. And if you guys are kind of developers and you're the most powerful it's one of the most powerful web servers in the world, and it kind of replaced Apache. And it's basically by using this extension called OpenRecipe, which allows us developers to basically create scripts to extend Nginx. We were able to bring COM to basically the whole world. And why am I talking about COM? It's because, first of all, it's entirely open source, so you can go online, download it for free, and run it on your server. And also because, you know, obviously I developed it, but it's really extensible, and I think it's really cool, and it can help a lot of you who are getting started, or maybe already in the Internet of Things /API world. How does it work? Well, it's very simple. You have like a REST API that allows you to configure and manage COM to create new users, to create authentication for all the developers that want to consume the data. It's built, like I said, on top of Nginx. Very simple to configure with YAML files, so it's very simple and kind of plain text to use. It uses brand new technology like Cassandra, and it's very error resilient and faced for a lot of time, and therefore it's battle tested. And it's extensible because using Lua script, which was invented in Brazil, you can create your own plugins. So, for example, if you want to just get a simple idea of how Docker works, these are the only two commands that you need to input in your computer or in your server, and you will have an instance of Kong working. And from there, you can start managing all your APIs without having to write a single line of code, which means your developers can focus more on doing what they like the most and do less of the boring stuff. And then this is an example of how you create your first API, which is then managed by Kong. But let's not talk about this now. I will share the slide later. Okay, so these are some of the available plugins that are really interesting for anyone who develops APIs. You can do basic authentication, which is like the simplest way to identify a user that might want to consume an API and therefore access all your data. You might have more like hard authentication that uses a key, or like the most preferred one by the web developers, which is OAuth. There are a lot of other plugins. I'm not going to try and sell it to you. All this information is entirely available on the internet. The project is free to use. There is no cost associated with it. Just Google for Kong, and then you will see Kong API management, and you will click and you get all this information. However, and there's always a however, every time something is developed, we always think, but why? Why should I use the Internet of Things? Is the Internet of Things safe? How can I protect myself? Exactly, like in the same way where people can just like stalk you on Instagram and understand at what times you leave your house to go to the party to then break into your house, you should be aware that creating Internet of Things devices and services are of utmost importance. You need to secure them. You need to make sure that no one but the people that are allowed to have access to the data. You don't want to get people snooping on your personal data. All your data is in the cloud, right? So for example, if I have an Internet of Things system inside my house that allows me to open the door without having to have a key, by just using my telephone, and this way I can also issue software keys to my friends so they can open the door by itself. What if a hacker decides to intercept that data and creates a key for himself? That's really like annoying. If I'm somebody who's going to buy such a system, I want to make sure that any manufacturer, any developer that works in the system has made every step possible to secure my data using any kind of possible technology that's out there. So, you want to be kind of like this guy, right? He uses his head. You want to try and be the guy that uses his head, but you don't want to be the guy that uses. I hope you enjoyed it. Follow me on Twitter or feel free to email me. I kind of reply at any time of the day. Try and go and build something awesome, hopefully, with whatever you've learned or you might have liked from my presentation. And remember, the internet is great because just Google, in a few seconds you get access to thousands and thousands of articles and tutorials, and therefore make use of the internet and be awesome. Thank you very much, and hopefully you have a great night.
Ele quer ver vocês, hein?
Bom, muito obrigado, Orlando. A cabeçada do Dani foi tão forte que o slide caiu, né, até hoje.